better now that my Zoom is working.
Zoom has been icky all day, and I've got one girl that I haven't heard back from, and she was just here. She led the workout, so I know she's somewhere out in space, but somewhere out in space. So hopefully she'll get back in here. So I want everybody to go ahead and pin Miss Kirby's screen.
If we get lucky, my cat might jump up behind me.
You still got the cat, huh?
Oh yeah. Oh, here she is.
Oh goodness.
This is Rebel. She will more than likely interfere at some point.
That's okay. That's okay. We have two now. We have got a brand new one this week. And I'm not going to say it's going real well. I mean, the cat is fine, but it's not going real well with the old one. So, all right, she's coming in here. So, Miss Kirby, Halo has evolved into something more than just martial arts girls now. We still have our squadron, and we've been practicing as best we can since we've been in, since COVID hit, and our practice facility, which is the church that I go to, is shut down. They are not allowing anybody in until August. So we're practicing over Zoom, which is really interesting. But we also do this. We're also advocating for women in other ways as well, in education, in breaking stereotypes, but also not being afraid to be a girl. And I know that you are right there with me because pretty much any woman that takes martial arts is there. So one of the things that I'm trying to do is I'm trying to expand their horizons and get an idea of the world around them, become responsible for that and also look down the road, not be so limited in what their career choices are. So
awesome. So
how many of you, Miss Kirby taught at our school and competed in the ATA here in Region 109 for longer than I did. How many of you remember Miss Kirby? Okay, so some of it, cool. And you probably remember some of those faces as well. So I'm going to let you go ahead and just introduce yourself a little bit and tell them your background and a little bit about yourself and what you'd like to talk to us about.
Okay, and I actually came prepared with a PowerPoint and everything, so I will screen share. Could you allow me to share screen?
Yes. How do I do that, Haley? I'm getting my tech support back here, so.
Go to settings on Zoom, and then it should say allow all participants to screen share.
Where is the settings at?
Or you can just do where you
it's on the just make her a co-host. How's that?
That works.
It's on the screen share at the bottom.
Yeah.
When you go to screen share, there should be a little arrow.
While she starts working on that, if you click the share screen at the bottom of yours, it should give you the option to allow other or multiple participants to screen share. But while she's talking about that, I'll start off. My name's Eileen Kirby. I have a pretty extensive background in environmental studies, which I know is the topic of this week. So I thought I would go through kind of a general overview of how broad the field can be, and then do a little bit of a deeper dive on climate change, because that's something that's really relevant to today's society. You guys have probably heard either your parents talk about it or maybe read about it in the news, depending on where you're at in life and participation with that. So yeah, let me see if I can, still having trouble sharing the screen here.
Yeah, we can't figure out, it doesn't allow us to make you a co-host, or, which I've never had that problem before, maybe because we're in my personal room.
Got it.
I can make you the host and then you can switch it back if you want to do it that way.
Sure, or I can also, I'll email you a link to the thing and you could also click through if you wanted.
Well, record.
Just make her the host.
Okay, I'm just going to make you the host and then you can.
I think at that point that would just be easiest.
Okay. Good. All right, there you got it.
Ah, there we go.
goes.
All right.
Next
So
person.
yeah, this week's, and I'll do my best to answer questions as they come up and go along. I'm not able to see everyone as I'm screen sharing, so maybe Ms. Rieger can help me out if someone
Sure.
has a question. Let me know when I can pause. And,
If you have a question, go ahead and put it in the chat for everybody, and then I can point it out to Ms. Kirby.
yeah. So my background, I did my undergraduate degree at the University of Colorado Boulder. Got the Bachelor's of Arts in Environmental Studies with minors in Atmospheric and Oceanic Sciences. I was really into weather forecasting for a while, and then also space. And then my master's degree was in Minnesota, which has a little bit of a different climate than Colorado, much snowier. And that was a Master's of Science in Science Technology and Environmental Policy. So I've done both the science side, anything from field work or computational analysis of data points, and going out like into the lab and analyzing things under a microscope, all the way through negotiating with the governor on what policies are best, how to best get drinking water for the state, things like that. So there's really a broad amount of things you can do, as you can see. Almost any science that interests you, you can apply to environmental studies in some way. Biology, chemistry, physics, geology. If you can add an ology to it, you can put it in the environment. But there's, outside of the hard sciences, there's also a lot more human-centered interactions and careers that you can have with it. Anything from sociology, so how people interact with the environment around them, whether or not there's fair and equal access to different environmental resources like state parks. You can go from a public health standpoint, water, drinking water, or even just swimming water quality, agriculture, natural resource management, and economics, and climate change, of course, is a big one. And then I highlighted the ones in yellow that I've had pretty extensive experience with myself. So if you have questions, I'm happy to answer them about any of these, any kinds of careers you might be interested in looking at them. But the ones in yellow, I have a better handle on. So
I have a couple of questions already. Yeah. The first one is, what are the positive and negative impacts that Corona has on the environment? And if this is someplace in your presentation, go forward, and then we can answer that as well.
Okay, I'll give a real brief overview of that. One of the positive impacts of Corona, understanding that it's a really bad thing for everyone's health, is that it has slowed down the amount of people that are driving or traveling, and just the amount of economic production, which is bad in other ways. But what it means is there's a lot less fossil fuel being used right now. And it's giving us a little bit more time to work out what we're going to do about climate change. And also there's a lot of really cool pictures on the internet of places that have really bad air pollution from traffic, highway traffic. Those cleared up and the sky was much clearer and air quality got better when that traffic stopped. So when everyone was sheltering at home. So there are some mixed benefits there.
So the next question I have here is, how much of the ocean do we actually know of compared to space?
Oh, we don't know much about either. I think, and I would have to check my statistic on this, but I think we've explored 5 to 10% of the ocean, and that's more than we've done with space. But there's so much of the ocean that we don't know, especially in the deep trenches. And then space, I mean, we haven't gotten beyond the moon with human travel yet. We have some pretty cool telescopes that have seen back even all the way to what is theorized to be the Big Bang, so the heat birth of the universe. And you can when you have a telescope that looks far enough away into space, you can see, because light takes time to travel for instance, it takes 7 minutes for the sunlight to reach us. If the sun just stops shining briefly, it would take 7 minutes for us to notice. So if you go all the way, if you look far enough out, you can see light that hasn't traveled to reach us yet. And that's how we know the approximate age of the universe is with that really powerful telescope to see how far away we can see light.
That's really cool. And the last question I have right here is, can you explain, oh wait, oh man, they're coming in. To get your master's degree, what kinds of classes do you have to take in college?
So to get accepted into a master's, it depends on which program that you're going to take. Some undergraduate programs will have an option to do a 5th-year master's. So you get your degree and then you spend an extra year of 5th year at that same institution. And because you already have a lot of the background from that institution, it only takes 1 year and a couple more advanced classes to get to your master's. The types of classes that you take during and in those fields, it really depends what you want to do with it. So I took a couple environmental policy courses in undergraduate that prepared me for my graduate program. But that was the specific direction that I wanted to go in. There's a lot of options.
There are 2 more questions, but I'm going to let you go on a little bit and then we'll get to those 2.
Perfect. And yeah, and I was planning on answering like job questions and things like that at the end too, if anyone has more. In the last 2 years, the work that I've been doing, I'm an environmental researcher at the Water Resources Center at the University of Minnesota. So a couple of the big projects that I've worked on recently, I mentioned talking to the Minnesota Department of Health and the governor about the status of drinking water in Minnesota and how to move forward with future changes that can be made to better manage and to reduce the cost to the state and to people, while also there's a chemical or a compound called arsenic that is really prevalent in the groundwater just because of the types of soil and rocks that are in Minnesota. And when people drink out of wells, it can get into the water and it's not good for them at more than a small amount. So we're working on how do we educate people about the risks if they have their own well, how can we fund testing of those kind of wells and the water system and make sure that it doesn't become a bigger problem in the future. Another project that's kind of related that I'm working on right now is for aquifer storage and recovery, which is looking at whether it's practical or not to, whenever there's an excess amount of water, so say if there's a big storm and then we have all of this extra water sitting around, or if we're just not using that much, or if it's a really rainy year, can we store that underground in an aquifer and then pull it back up at a later time when it's maybe a drought year? It's done all over the West. It's not done so much in the Midwest. I know Colorado has a couple of these systems, but looking at developing that here. And then more on the agricultural side, I'm working with soil health policy. So how can we encourage farmers to use best management practices for their crops so that it keeps their land healthy and also the rivers and streams and wetlands around them healthy. I've also been in the last 2 years to 2 different countries for international climate negotiations, climate change negotiations, and I wrote my master's thesis on disaster evacuation policy. And a thesis is one of those things that you have to do at the end of a graduate degree to, it's like a big project that you work on your whole time in school, and then you write a big paper, and very long paper, and you present it in front of people and they decide whether the work is of high enough quality. So that's one of those steps if you're looking at maybe getting a master's degree or a doctorate, a PhD, that would have to do. So today I thought a little bit of a deeper dive into climate change because like I said, it's a very relevant topic, and it's also not one that a lot of people are informed about when they talk about it. You hear headlines and then people say, oh, it's bad, oh, it's good. It's actually a very physical process with a lot of science involved, but we're going to break it down just a little bit so that you guys can, talk with friends about it, or maybe pull up points in conversation at dinner with parents. So this is a diagram of the Earth and the Earth's atmosphere. The atmosphere is what makes it so that we can live on Earth and not need spacesuits. the vast majority of it is in the troposphere, this bottom layer here. So raise your hand real quickly if you've seen these types of big thunderstorm clouds out in the distance maybe. Yeah, so the very tops of those clouds are at about the height that planes fly, and that's right about where the border of the troposphere and stratosphere is, the two lowest layers of the atmosphere. So everything that's weather related or anything, that all happens in the troposphere. And that's where most of the things that we're interested in for climate change happen. I had a question. What do you guys think is, and maybe you can type the answers in the comment box to Ms. Rieger, what do you guys think is in the air that we breathe? What? You can read out the ideas as they come.
O2,
Yeah, oxygen, good. Any other guesses?
nitrogen, oxygen, CO2, and methane. Carbon dioxide and oxygen.
Awesome, you guys got a lot. Yeah, so oxygen is about 1/5 of it. The rest of them are totally fine to breathe in these small concentrations. And then nitrogen, also see-through, odorless, tasteless, fine to breathe. Oxygen is obviously the part that we use while breathing. But for climate change, the type of gas that we're really interested in is a greenhouse gas, and carbon dioxide is an example of a greenhouse gas. And essentially what a greenhouse gas is even though they're in really small amounts in the atmosphere, they have a big impact. So like if you had 10,000 pennies, only 4 of them would be carbon dioxide. So that would be $100 in pennies, but just 4 cents of that would be carbon dioxide. But those 4 cents are what make Earth habitable for us. So there's a lot of stuff on this diagram. Don't worry, we're gonna ignore the entire left half at first. And I'll break it down. So I'm getting completely rid of that left side of the screen, all of the human interactions. But a lot of you might have seen in school at some point the water cycle, with precipitation, and the water goes down in the river, evaporates from the ocean back, that kind of thing. Yeah, I'm seeing some nods, cool. So carbon dioxide has a very similar cycle. There's always some amount of it in the atmosphere keeping us warm, but there's also carbon dioxide, plants breathe it in and use it as the building block, and it gets stored in trees and other plant matter. Until those plants decompose or are lit on fire or things like that. It also is stored in the oceans, and the atmosphere and the ocean really like to maintain a balance. The Earth likes to be evenly spread all over the place, with whether it's the temperature. One of the reasons that we have weather systems is because it's warmer in one place and colder in another place, and the Earth is trying to make it all one temperature across the whole surface. That never happens, but it's kind of the same thing with carbon dioxide. So some of it is stored in the ocean. If there's less in the air than there is in the ocean will start to release it. If there's more in the air than there is in the ocean will start to absorb it. And then when you have, moving back to the land plants that store it, when those decomposed plants they build up layers and layers, and over hundreds of thousands of years, they begin to compress and they change a little bit, and that's what creates oil, coal, and natural gas. So a lot of the things that we're burning for energy today was actually plant life about when the dinosaurs were on Earth.
Do you have time for a couple of related questions?
Yeah.
Okay. How do you capture gases and test gases to know what they are?
There's a lot of cool ways. I took a biometeorology class, and you can use this really high-tech kind of radar. These gases have different sizes and weights, even though they're all very light and very small. And what you can do is use a laser as wind or something else moves through, and you can set the laser or the output. So there's like a laser on this side and then a receiver on this side. And as air moves through, the molecules will interrupt the flow of that laser, and you can get an idea of about how many of those molecules there are, what types they are based on their approximate atomic weights and sizes. And so you can get a pretty good idea that way. There's also gas canisters. You can just literally get a container of air and then analyze that in the lab. But the flux pesometers, I almost said flux capacitors, but this isn't.
I thought that's what you were, I was like, that's a thing.
No, the flux pesometers are able to pick it up in real time and measure, let's say, even the amount of oxygen that's leaving the leaf of a plant. It's pretty cool technology.
So what are ways to curb CO2 in the atmosphere other than the use of renewable resources and decrease of fossil fuel use?
Great question. There's a lot of different ways. So one of them that gets created is geoengineering. There's a lot of different concepts there, but carbon capture and storage, CCS, is one that you'll hear about a lot. And they've created artificial trees that can pull carbon dioxide out of the atmosphere and then store it in either canisters where they compress it until it's liquefied, because it's under such intense, it changes from a gas to a liquid state under such intense pressure, and then that can be injected into the ground. That's one way, and we'll get into a little bit more of that later.
All right, go forward.
Oh yeah, and I just wanted to, so when I was talking about the ocean and the atmosphere balancing each other out, it's really important to understand it never quite does it, because the Earth always overshoots a little bit. It doesn't respond quickly enough to, as soon as they're at even, to flatten out. So the ocean will get too much even when it had too little, and then it'll come back out. And from that we get kind of varied temperature cycles in the atmosphere. In addition to, there's all kinds of, the tilt of the Earth changes on 22,000, 44,000, and 110,000 year time frames. So there's a couple different ways that we expect to see temperature change, but one of these is the cyclical nature of this carbon dioxide emission and then absorption again into the ocean. And we'll get back. So really quickly, the greenhouse effect is the term that we give to these greenhouse gases. And the reason is because they act in the atmosphere just like a greenhouse. If you've ever walked into a greenhouse, especially in the winter, you know, the sun can come in through the glass ceiling, but then the material prevents all of that heat from getting back out, so it stays nice and warm inside. And that's essentially what carbon dioxide does. It lets the sun in, and then when the heat comes back out from the Earth, or other greenhouse gases as well, it gets trapped kind of by that greenhouse gas layer, just like the roof of the greenhouse. So when you add more carbon dioxide into the atmosphere, or more greenhouse gases, it's like thickening the outer layer of that greenhouse. It's making it a lot harder for that heat to get out. So this is all very well and good. Like, the climate has changed before, you might say. What's different this time? And it's like those cycles that we talked about. There we go. We see kind of that periodical, cyclical nature of, you know, there's more carbon dioxide, there's less carbon dioxide. And temperature graphs look almost exactly like this. This is on the y-axis here, we have carbon dioxide concentration in parts per million. So higher up, there's more of it in the atmosphere. Lower down, there's less of it. And then time moves from left to right. So this is 800,000 years ago, forever ago, all the way up through, I believe this was a 2018 figure. Yeah. Yes, my screen was covering it a little bit. But so what's changed here? Well, right around 140 years ago, the Industrial Revolution happened. And about 1880, we started using electricity and gases on a much larger scale. And what that did is bring the entire left side of this graph back into play here, or this diagram. So humans dug up the oil, coal, and natural gas, that stuff that carbon dioxide that normally would just be sitting there if we weren't using it. And then by combusting it and increasing human agriculture, we're adding that extra CO2 into the atmosphere. And that's what has caused this rapid uptick here very quickly. So the reason it's different is because of how quickly all of this is being added back in. Where are these additional gases coming from? In the US at least, the vast majority of it is from transportation, electrical generation, industry, and agriculture. Commercial has some parts of it, and residential use, so you and your family at home, has a decent slice in there too. But overall, this is the breakdown. And then agriculture, it's interesting in all of the different graphs put out by the governments and scientists on this, agriculture gets broken down differently. It's about 40% of our annual greenhouse gas emissions comes from agriculture, but in this particular one, it gets broken down based on transportation. So if you ate a mango in December, it had to be brought all the way to Colorado from somewhere that was much farther away on a plane, or all of that processing adds to the carbon impact of that mango. So agriculture can be anywhere from a low to fast higher number there.
So I just got notice that we're running close to end of time. So would you mind if I just put the questions out here for you?
Sure, absolutely.
So this goes, I'm gonna start with the ones that directly related to what you were just talking about. Is there a possible way that we can take the greenhouse gas in the atmosphere and somehow convert them into energy to move cars?
That, I think it's possible. I don't have the specific research on that, but hypothetically, what's happening when, I mean, that's what's happening with the combustion of the organic matter and the fossil fuels, and then releasing that up into the atmosphere. There could be some kind of propulsion from that, but I would have to do more research into what specifically that would look like. I do know that that is not a current, it's not a current possibility. That technology is not developed yet, if it will be. So,
is methane a greenhouse gas?
It is. Methane is a greenhouse gas, and it's about 4 times strong, or 40 times stronger than carbon dioxide. So,
okay. So here's an interesting one. If Corona was not around, where would you be right now?
I would still be in Minnesota, but I would likely be traveling more to different conferences and things like that. So I would still be doing about my same job, but I would be participating in a lot more academic conferences and climate negotiations.
Okay. Do you ever practice drills for if we have to store water underground?
So it wouldn't be necessarily so much of an emergency situation thing that you need to drill. Are they asking for, do I do the drilling into the ground, or like a practice?
Yeah, practice, I think. I think
Okay.
a practice.
Yeah, so there are a lot of these projects up and functional, and you do, before you create a big old project with that, you do something called a pilot project, which is at a much smaller scale to make sure everything is safe. So in that way, you kind of do a practice before you store the water underground to make sure it's safe, and that when you pull it back up, it's still clean to drink.
Okay. And then the last one I have is, can you explain what and how economics mixes into the field of science?
Absolutely. So the projects that I'm working on right now with aquifer storage and recovery, there's, I think, 6 different project teams. One of them looked at study areas, just identifying it. One of them did all of the geological and hydrological modeling. So they did the very hard science and went and took the water, tested it, tried to see what the reactions were when they added different types of water and different amounts of oxygen into it, to try to figure out what would happen if you add a different type of water into that aquifer. And then part of the team that I'm on is the policy and economic analysis. So how much is it going to cost to do even the science and the pilot projects that you might need to do? One of the big parts of economics with the environment is valuation. So if things don't have a clear money value, like you can't put a value on clean water, you can't put a value on knowing that there is a completely untouched wetland somewhere. But what economics tries to do is to translate those values for the scientists to say, here's what's important to people, here's what people are willing to pay to preserve this kind of resource, here's what people are willing to lose in favor of other benefits. So there's a lot of different things you can do with economics there, and I'm happy to be a little more specific if needed. So
Elena, how much time do we have left? She's our usual timekeeper. So we're not on a paid account, so it kicks us out after 30 minutes or 40 minutes. That's what usually happens.
Okay.
We have 5 minutes left. So you are welcome to finish up, or we can start a new chat or a new room too.
Okay. I can zoom through this last part here and then see if there's any more questions. I'm happy to stay for as long as people have questions, if it's in a new room or whatever.
You guys have been amazing, and we thank you so much too, Meow. So I'll let you go ahead and finish what you would like to share.
All right, so why does it matter that climate change is happening right now? Well, you guys are very smart, obviously, especially from the questions, you guys have great questions. But slow response time on this PowerPoint today. But it matters for agriculture. Droughts will impact food production, and even just shifting of regions where food currently is grown and has been grown for generations, they might become less viable for it. Extreme weather events, so either precipitation in landlocked areas can cause flooding. Some of you guys might be old enough to remember in 2013 when we had a bunch of rain in Colorado and the mountains flooded and a lot of bridges got shut down. I actually got stuck out of town when I was living in Fort Collins because all of the bridges across the river were closed. Climate change also causes not just extreme heat and more heat, warmer, but also because of the energy that it adds to the atmosphere, can cause some extreme colder snaps too. And as someone who's recently lived through a negative 55-degree winter, it's not fun. So
welcome to my life.
And then there are obvious health impacts that go along with, for more vulnerable populations, older, those with underlying conditions when it's too hot or too cold out. The other thing, one of my projects or biggest interests is environmental justice and equality. And if you think about the countries and the people that have been allowed to use all of the fossil fuel resources that are causing this warming and causing this addition of CO2 into the atmosphere, those areas are generally not the people and the areas that are most impacted negatively by climate change. When I went to the climate negotiations this past year, there's an alliance of small island nations, and they have a very minimal carbon footprint. They have so many trees on their islands, and the nation's Fiji is one of them, that they actually have, in some cases, a net negative carbon impact, but they're the ones that are being threatened by things like sea level rise and greater heat extremities. And then I have this very quick video, if it will load, which it might not. Well, we are running out of time and it doesn't seem to be loading, but it, if you guys are interested, I can send Ms. Rieger a link. It shows the temperature trends since 1880 across the whole globe.
I'll be sending out a link with all of the assignments for this next coming week. So yeah, send it and I'll go ahead and send that on with them.
Cool. Yeah, so what can we do? The small things really do add up, even though our individual actions only make up a small portion of the carbon emissions and the fossil fuel emissions. Things like substituting white meat or veggies for red meat in your diet, even just once a week, can reduce your personal.
By now, you're surely picked up on the idea that the study of natural history is basically the study of how the world has changed. The study of how we all got here.
Don't know.
Miss Rager,
Yes.
we only have like not even a minute left.
Did you want to, Ms. Rieger? Wait, less than a minute left.
Yes. Mine says 106, but
Okay.
so yeah, if you want to just finish it up and we'll be good.
Yeah, so there's a lot of options. I was going to take like your ideas for ways that you can reduce your own impacts. I'll send this along too. But it's pretty easy to make small changes that help the planet in a big way, especially when a lot of people do them. And then the other good news is we're working on it. Like, countries are negotiating to figure out the best way to make sure that countries that got the opportunity to develop are able to help fund the countries that haven't had that kind of chance and take more of the responsibility for climate change. The negotiations are ongoing, but there is progress being made.
Awesome. So since if you have any more questions for Ms. Kirby, this would be a good time. If they're short ones, or if you have, sorry about that.
Oh, that's my bad. I was given a time allotment and got too excited.
Well, and Izzy's here already, so I think she has some questions and wants to finish up because she was, dang it.
Yeah. No, I'm happy to.
Elena. Well, you were very popular tonight. This went very well. I'm impressed. But they were so interested, and you did a great job.
Thanks. This was really fun.
Halo's really fun. It's been an eye opener for me, and these girls are amazing. So,
I can tell. Yeah.
If you know of anybody that since right now everything's remote, you know, link them in. And it's not just for the young girls either. It's sorry. See, this is the newest member of our family.
Oh my gosh. Oh, she's gorgeous.
Yeah, she is really cute, and she's kind of infectious on us, but she has caused holy hell in her house. All right, so Ms. Kirby came back with us just to answer any more questions that you guys have, or so if you have something, this is your opportunity. So we don't want to keep her time too much. So you can go ahead and just unmute yourself and ask anything you like.
Or swing a stick around. That works too.
Swing a stick around. Yeah, some things never change. Izzy, did you have something you were going to ask?
Yeah, I did, but then I just forgot it, which sucks.
Sorry.
Well, if you think of it, let her know and she can ask me. I'll get back.
Yeah.
Okay.
I'm happy to answer any more questions about like why I chose environmental studies or what that process looked like more specifically going through college and grad school. Really whatever you guys are interested in. Or
What made you want to go into this field of study?
So my parents like to joke that there was no way I wasn't going to go into something environmental because I started conducting thunderstorms when I was 2 years old. My family is a big music family. They expected everyone to go into music, and I was like, no, I'm going to conduct the weather. So I thought I wanted to be a weather forecaster, and I took all of the courses that I really needed to do that in undergraduate, and it's still definitely a passion of mine, and I forecast my own weather sometimes to compare it to what the forecast is going to be. But the realities of that job as I was looking into internships and job application was sitting behind a computer most of the day, and there wasn't much travel involved, and the hours were kind of weird because you have to have weather forecasters on at all times. You have to move pretty much wherever there's an opening in a forecast office, and then you take whatever shift isn't taken, and it's normally the 12 a.m. to 8 a.m. shift. So I wanted something that I could interact with people a little bit more and have a much broader scope. So I get to work on all kinds of different projects in the environment, and all of them are interesting because of that common thread of they're environmental for me, and I get to help people, but they're keeps me interested. It doesn't get boring.
So with the agricultural impact, because, you know, being Minnesota, it's Midwest, it's not, you know, I mean, it's not the big farms like you have in some of the other states, but it's still fairly agricultural. What do you see coming there? Because I have a lot of people that I know that are, you know, I come from a farming family, and most of them are still in that industry. What kinds of things do you see happening in coming down the pipeline?
So a lot of, and this is partially because I'm starting the soil health project, but there's a lot of more conservation techniques, land conservation techniques, that are being more widely accepted as best management practices, whether it's letting fields lay fallow for X amount of time every 7 years or so, having that rotation. And Minnesota specifically in 2018 with the Farm Bill implemented buffer zones. So if you have an agricultural field, you can't plant and or fertilize within X distance of a stream bed, so to prevent the runoff of the fertilizer and nitrogen and pesticides as well from going into the direct water stream. So those are a couple different things. But then honestly, the shift, it's going to take changes in crop insurance legislation and changes in the subsidies for which crops are currently being grown for there to be any real meaningful shift to more sustainable general farming instead of just these big monocrop agriculture production.
Okay, cool. That's so, and what about water quality? I mean, you have a lot of small towns in Minnesota, and the water quality in some of those small towns, you know, because I have one, I come from one, and I can't stomach the water in my hometown anymore. I don't think it tastes bad. I don't like the way it looks, but it does adversely affect my digestive system. Nobody else. So when we moved back here, we had the water tested, and it came back with, I believe it was copper sulfate, which is basically anhydrous ammonia, correct? Is that the main component?
I'm not entirely sure, but yeah.
Okay. So what do you, you know, since water storage is kind of one of your fields there, what can some of those smaller areas afford to do to make sure that their water supplies are safe?
Well, that's the big question, right? There's all of this fancy water distillation and purification technology, but if you're working with a very small town, often a city council member is also the person in charge of all of the operating plan decisions, and it's just such a local. I'm curious, do you know if you're on groundwater in your hometown or surface water? Well, yeah.
Well,
and is it a private well, or are you hooked up to the city there?
They're hooked up to the city. Now, my mother has her own well, but that water is fine for me.
Okay.
And they're in 5 miles from each other, but her well is deeper than that one is.
Yeah, that makes sense. A lot of times, so they won't let it come through the city if it doesn't meet the national drinking water standards. So what you're drinking is safe for your body or for the average human body to have in one sitting and then over an extended lifetime. They have the different maximum contaminant levels that are allowable for each of those. But it's likely, like, it could be a different concentration of things maybe that you're specifically susceptible to. And I would say, I don't know, I would also look into the pipelines that are going into your house, because that could be, if it is the city water that's bothering you, and then well from a different pipeline isn't bothering you, if it's likely on the same aquifer, even if it is deeper, it might be the distribution system that's a little bit more part of that issue.
And the water is very yellow too. It's very yellow. So, you know, that could play into it.
Mm-hmm. Yeah.
Okay.
The water could be bright pink and still safe to drink, but no one would want to.
Yeah.
Well, everyone there doesn't care that it's pea yellow.
On a household by household basis, one thing that can often be smaller, because you were asking about, you know, small town, smaller distribution system, often the connection fees are what create the budget for the water system. And if you have very few people, you have to have much higher connection fees to be able to get anything done and to maintain the facility. It might be cheaper to, instead of improving the treatment plant, to use those connection fees to save up and work with a distribution system for personal household filters. They have under sink, they're about $400-ish that you can install reverse osmosis things, and it's just like this little thing that you put on your faucet for kitchen tap water, and it's very effective. It'll remove any excess arsenic, and it helps with flavor, especially, I found. So that's something that at maybe $400 a house for a small town is a lot more feasible than a multi-million-dollar treatment plant upgrade.
Right. Right. All right. Well, does anybody else have any questions for Ms. Kirby? If not, we will stop taking up so much of her time. But I really enjoyed this. This was great. So
happy to do it.
All right, unmute and let's give her a salute, ladies. All right. Thank you, ma'am. I'm going to send out assignments for next week, because I do believe we have Father's Day looking at it. Is our next process that we're working on, and it's going to be makers. So you're going to be coming up with solutions as a gift. So I'll be sending that out in an email. So if it doesn't come to you, make sure that mom and dad get that information to you. So, all right, everybody, thank you so much. Go have dinner, except Milena, because she's eating her weight in goldfish. All right, we'll see you guys. Bye-bye.
Bye. Bye. Bye.